Welcome to our video. In this video, we will talk about the body system. We can call the body system a RAM management algorithm used in operating systems. It uses free lists. It splits RAM into powers of 2 and allocates the memory like that. Then it frees it again. And now let's imagine we have a 16-byte RAM as our example. And we will assign different programs to it. For example, program 1 needs 2 bytes of space. Let's think about how the body system handles this. First, the body system splits the 16-byte RAM into two 8-byte parts. Then we have two 8-byte pieces. We can use this for our 2-byte program, or we could use the full 16 bytes. But to be more efficient, instead of using one of these 8-byte blocks, we split them again. Now we get two 4-byte blocks. We can use these two, but if we split one of these 4-byte blocks again, we will get two 2-byte blocks, and that's the perfect size for what we need. So the body system splits the RAM into about 4 pieces. Two 2-byte pieces, one 4-byte piece, and one 8-byte piece. And it allocates one of 2-byte blocks for program 1. Now let's say another program runs after this. This is the program 2, and program 2 needs 3 bytes of space. Now we have different options for this 3-byte space. First, a 2-byte block, second, a 4-byte block, and third, an 8-byte block. We can't use the 2-byte block because it's too small. We could use 4-byte or 8-byte block. The body system chooses the smallest suitable one. And if it needs to split it, it splits it. If it doesn't, it just uses it. For example, if we had 8 bytes and 16 bytes and needed to split one, it will pick the 8-byte one instead of 16 because it's smaller and already split into 8. Instead of splitting 16 into 2 8s, it will split 8 into 2 4s and reduce the work. Here, we choose 4-byte block. The 2-byte block is too small and the 4-byte block fits, and the 8-byte block is bigger than needed. So body system chooses the 4-byte block, and we assign the program 2. Now program 1 uses 2 bytes and program 2 uses 3 bytes, and we have 1 byte of internal fragmentation. The red marked area is internal fragmentation. It's the unused space inside of the block. We can't use this part anymore because the 3 bytes didn't allow us to split the 4-byte block further. So we had to use the full 4-byte block for program 2. Even though program 2 doesn't need the extra 1 byte, we can't use it for a new program. Now let's look at the next program. Program 3 needs 1 byte. Our RAM looks like program 1 uses 2 bytes, then 2 bytes free. Program 2 uses 3 bytes, 1 byte free, and an 8-byte free block. Where should we place program 3? At first, the 1 byte free space looks fine, but it's internal fragmentation, so we cannot use it. That leaves the 2 byte and 8 byte blocks. Instead of splitting the 8 byte block 3 times, the body system chooses the smart way and splits the 2 byte block, and 1 byte pieces go to program 3. And the remaining 1 byte block can be used by another program. This is not internal fragmentation because the block was split perfectly. Now we have program 1, program 3, a 1 byte free block, program 2's 1 byte internal fragmentation, and an 8 byte free block. This is how body system works. Now let's talk about advantages and disadvantages. First, the advantage: less external fragmentation. This is the opposite of the internal fragmentation. In external fragmentation, the space is usable but scattered, so it can't match the program's size. To summarize external fragmentation, if the RAM has one clean block of 8 bytes, an 8-byte program can be placed easily. But when the free space is scattered into the smaller chunks, like a few bytes here and few there, then even though the total free space is technically enough, the program can still not fit because it needs one continuous block, not pieces spread around. Like in our earlier example, there were 9 bytes of usable space, but since some were on the left and some were on the right, the program couldn't fit it. That's external fragmentation. The red marked space, though, was internal fragmentation. That's the difference. The body system creates less external fragmentation because it keeps blocks in body pairs. When a block is freed, it joins its body and becomes a larger block again, so it reduces the external fragmentation. It also allocates and frees memory faster because finding the body only needs checking a single bit. That makes it fast, and thanks to free list, management is simple. But there are disadvantages also. It causes less external fragmentation but more internal fragmentation. As we saw with the red block, unused space inside the block can appear. It's also less flexible because block size must always be in power of 2, so we can't call it really flexible. Then that's the body system in short. I hope it was helpful. If there's something missing or wrong in this video, or if you are curious about something, just let me know in the comments. So take care of yourself. See you.